Most engineers assume heapq.nlargest always uses a heap. Python's source code tells a different story. For n equals 1, largest simply calls max, no heap at all. For 2 or 3, it uses a similarly fast path. Heap overhead just isn't justified for tiny results. For moderate n, largest seeds a min-heap with the first n elements, then iterates the rest. When it finds a value greater than the heap's minimum, it calls heap replace to swap them. This keeps the heap at exactly n items, always holding the n largest seen so far. The heap approach runs in O of n log k. N is total input size, k is how many you want. Top 10 from a million items, roughly 3 million operations. Sorting the full list is O of n log n, about 20 million. For small k, the heap wins by an order of magnitude. But heap maintenance has real overhead. Ask for the top 300,000 from a million items, and all those push-pop cycles cost more than sorting. CPython checks if n exceeds roughly 1/3 of the total size. If yes, it calls sorted in reverse and takes a slice. Timsort wins at that scale. Largest picks max for tiny n, min-heap for small n, and sort for large n. Follow for more Python internals. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.